Welcome to our channel. Today, you'll step into the incredible life of Albert Einstein, a boy once seen as slow, who grew up to change the future of humanity. This is not just a science story, but a powerful lesson about curiosity, failure, and believing in yourself. If you enjoy inspiring true stories and want to improve your English while learning something meaningful, don't forget to subscribe and join us for more stories like this. A slow start. March 14th, 1879, dawned cold and clear in Ulm, Germany, in a modest apartment above a busy street, where horse-drawn carriages clattered over cobblestones and vendors called out their wares. Pauline Einstein gave birth to a baby boy. She and her husband Hermann named him Albert. The infant's head seemed unusually large and oddly shaped. His grandmother gasped when she first saw him, exclaiming, "Much too fat, much too fat." The back of his head was so angular that the family worried something was wrong. But the doctor assured them Albert was healthy, just different. Albert was slow to speak. Most children begin talking around age 2, but Albert remained silent. At 3, when other children were chattering constantly, Albert barely said a word. His parents grew concerned. His grandmother whispered that he might never be normal. Finally, at dinner one evening when Albert was nearly 4 years old, he suddenly spoke his first full sentence: "The soup is too hot." His parents were overjoyed and relieved. "Why haven't you said anything before?" they asked. Albert's reply, though probably invented later, became legendary. Up to now, everything was in order. This story, whether true or not, captured something essential about Albert. He thought deeply before speaking, and he saw no reason to talk unless he had something meaningful to say. The Einstein family lived in a comfortable home with high ceilings and tall windows that let in streams of German sunlight. Hermann ran an electrical engineering business with his brother, and the house often smelled of metal, oil, and the ozone scent of electrical equipment. Young Albert would sit on the floor of his father's workshop, watching sparks fly from machines, fascinated by invisible forces creating visible effects. The compass, a first wonder. When Albert was 5 years old and sick in bed, his father brought him a gift that would change his life: a simple magnetic compass. The bedroom was dim, curtains drawn against the afternoon light. Albert lay propped up on pillows, bored and restless. Hermann placed the compass in Albert's small hand. The boy watched, mesmerized, as the needle swung and then steadied, always pointing north. He turned the compass. The needle moved, then returned to north. He turned it again. The same result. Albert's eyes grew wide with wonder. Something invisible was moving that needle. Some force he couldn't see, couldn't touch, couldn't hear, yet it was real and powerful. It worked the same way every time, following rules he didn't understand but desperately wanted to learn. "What makes it do that?" Albert asked, his voice filled with awe. "Magnetism," his father replied. "Forces in nature that we cannot see." That compass awakened something in Albert, a burning desire to understand the invisible rules that govern the universe. Years later, he would write that this experience produced a wonder of such nature that left a lasting impression on him. From that day forward, Albert wanted to know, what are the hidden rules? What forces shape our world? What lies beneath what we can see? School years, a rebel student. At 6, Albert entered elementary school in Munich, where the Einstein family had moved for Hermann's business. The school was a stern, imposing building with gray stone walls and narrow windows. Inside, wooden desks sat in rigid rows. The air smelled of chalk dust and floor wax. German schools in the 1880s were strict and militaristic. Teachers demanded absolute obedience. Students had to stand when answering questions. speak only when spoken to, and memorize facts without questioning. Creativity was discouraged. Individual thinking was seen as disrespect. Albert hated it. He sat at his wooden desk near the back of the classroom, watching dust particles float through shafts of sunlight from the high windows, while other students recited multiplication tables in unison, their voices echoing off the walls. Albert's mind wandered to more interesting questions. Why is the sky blue? How far do the stars extend? What is light made of? His teachers called him lazy and disrespectful. When Albert asked why, about things they told him to simply memorize, they saw defiance, not curiosity. His Greek teacher told him, "You will never amount to anything." Einstein. But Albert wasn't stupid or lazy. He was bored by rote memorization and frustrated by teachers who couldn't answer his questions. He excelled in mathematics and science, subjects where he could discover patterns and understand principles, not just memorize facts. At home, in the warm glow of gas lamps illuminating the family's parlor, Albert found refuge in books. His uncle Jacob, who worked with Hermann in the engineering business, gave Albert algebra books. The symbols and equations were like puzzles to solve, and Albert solved them with joy. Algebra is a merry science, Uncle Jacob would say, sitting beside Albert at the dinner table covered with equations. We go hunting for a little animal whose name we don't know, so we call it X. When we bag our game, we pounce on it and give it its right name. Albert loved this game. Mathematics wasn't boring memorization. It was a treasure hunt for hidden truths. Music, the language of harmony. When Albert was 6, his mother Pauline insisted he learn violin. At first, he resisted, finding the mechanical practice boring. But everything changed when he discovered Mozart. One afternoon, in the family's music room, where afternoon light streamed through lace curtains, Albert heard his mother playing a Mozart sonata on the piano. The notes seemed to dance in the air, creating patterns of sound that felt mathematical, logical, yet achingly beautiful. Suddenly, Albert understood music differently. It wasn't about memorizing finger positions. It was about finding harmony, discovering patterns, expressing something beyond words. He picked up his violin with new passion. For the rest of his life, Albert played violin, which he named Lena, almost daily. When stuck on a difficult physics problem, he would play Mozart or Bach, letting the mathematical beauty of their compositions unlock his mind. The music helped him think, helped him see patterns, helped him glimpse the harmony hidden in nature's laws. Life without playing music is inconceivable to me, he would later say. I live my daydreams in music. I see my life in terms of music. The Wonder Years, Self-Education. At age 12, Albert experienced his second great epiphany. His parents gave him a geometry textbook, a worn book with a faded cover and yellowed pages covered with diagrams and proofs. Albert opened the book on a summer evening, golden sunlight filling his bedroom, birds singing outside his window. He began reading about lines, angles, triangles, and circles, but these weren't just shapes. They were truths proven through logic, eternal principles that couldn't be disputed. He worked through every proof, checking each step, understanding each logical progression. The feeling was intoxicating, like climbing a mountain and seeing farther with each step. Geometry showed him that pure thought, without experiments or observations, could reveal absolute truths about the universe. If I could prove something with logic alone, Albert thought, what else might I discover? That summer, Albert taught himself advanced mathematics far beyond what his school taught. He sat at his desk for hours, the lamp burning late into the night while his parents slept, working through calculus problems, exploring mathematical concepts that fascinated him. A family friend, Max Talmud, a medical student who joined the Einsteins for dinner every Thursday, became Albert's mentor. Max brought books on science, philosophy, and mathematics. They would sit in the parlor after dinner, oil lamps casting warm light on their discussions, talking about light, energy, atoms, and the nature of space. What if you could ride on a beam of light? Albert asked one evening, his eyes bright with curiosity. What would you see? This thought experiment, imagining himself surfing on light itself, would obsess Albert for the next 10 years and eventually lead to his theory of relativity. Leaving Germany, a new beginning. At 15, Albert faced a crisis. His family's business failed, and Hermann moved the family to Italy to start over. But they left Albert behind in Munich to finish his education at the strict German gymnasium. Albert found himself alone in a boarding house with thin walls and a hard bed, attending a school he hated, in a city that suddenly felt foreign. The Munich winter was cold and gray. Rain pattered against his window. The school building felt like a prison. One December morning, with frost covering the windows and his breath making clouds in the cold room, Albert made a bold decision. He would leave. He would quit school, give up his German citizenship, and join his family in Italy. His teachers were happy to see him go. He was too rebellious, too questioning, too different. One teacher signed his withdrawal papers with obvious relief. Albert traveled south by train, watching the German landscape change to Austrian mountains, then Italian countryside. As the train descended into northern Italy, winter gave way to milder weather. Olive trees appeared on hillsides. The sky grew brighter. Albert felt like he was escaping a cage. Italy enchanted him. The family settled in Pavia, a charming town with cobblestone streets, Roman architecture, and people who laughed easily and gestured passionately while talking. The air smelled of espresso, fresh bread, and the nearby countryside. Palm trees swayed in the breeze. Everything felt lighter, warmer, more alive than Germany. For months, Albert wandered the Italian countryside, hiking through hills covered in wildflowers, sitting beside rushing streams, lying in meadows watching clouds drift across the blue sky. He thought about light, energy, space, and time. He filled notebooks with ideas and questions. But he couldn't spend his life wandering. He needed an education. At 16, he took the entrance exam for the Swiss Federal Polytechnic in Zurich, one of Europe's finest technical universities. He failed. His mathematics and science scores were excellent, but his knowledge of languages, history, and literature was too weak. The rejection stung, but the director recognized Albert's potential and suggested he spend a year at a Swiss secondary school, then reapply. A row, finding freedom. Albert enrolled in the cantonal school in Aarau, a small Swiss town nestled in green hills where the air smelled of rain and wildflowers. The school was nothing like the rigid German gymnasiums. Swiss education emphasized creativity, independent thinking, and questioning. Here, finally, Albert found teachers who appreciated his curiosity rather than punishing it. The classrooms had large windows overlooking the Alps, mountains that seemed to touch the sky. Teachers encouraged discussion, welcomed questions, and treated students as thinkers rather than vessels to be filled. Albert boarded with the Winteller family, a warm, intellectual household. Jost Winteller, the father, was a teacher who loved discussing philosophy and science over dinner. The dining room rang with lively debates, laughter, and passionate discussions about everything from politics to physics. The Winteller home had a cozy warmth, a fire crackling in the hearth, the smell of Mrs. Winteller's cooking filling the air, books stacked everywhere, and an atmosphere that celebrated ideas and curiosity. For the first time since leaving his family, Albert felt at home. He fell in love with Marie Winteller, the teacher's daughter, a sweet girl with dark eyes and a gentle smile. They walked together through the Swiss countryside, holding hands on paths lined with wildflowers, talking about the future. But Albert's heart belonged ultimately to physics, and the romance gently ended when he left for university. In 1896, at 17, Albert successfully entered the Zurich Polytechnic. He officially renounced his German citizenship, becoming stateless, a symbolic act of independence that reflected his growing sense that he belonged not to any nation, but to the universe itself and its mysteries. University years, the rebel scholar. The Zurich Polytechnic occupied an impressive building overlooking the city, with large lecture halls, laboratories filled with gleaming equipment, and a library that smelled of old books and possibility. Lake Zurich sparkled in the distance, and on clear days, snow-capped Alps dominated the horizon. Albert enrolled in the physics and mathematics program. His classmates were serious students who attended every lecture, took careful notes, and studied diligently. Albert did none of these things. He found most lectures boring and outdated. Instead of attending class, he would sit in coffee houses, warm, smoky rooms filled with the aroma of espresso and the buzz of conversation. He drank coffee, read scientific papers, and taught himself the latest physics theories by studying the original sources. Why should I listen to professors teaching old ideas? Albert reasoned. When I can read the papers of scientists making new discoveries? This approach frustrated his professors, particularly Heinrich Weber, who told Albert, "You're a smart boy. Einstein, very smart. But you have one great fault. You'll never let yourself be told anything." Albert made few friends among his classmates, but one friendship would prove crucial. He befriended Marcel Grossman, a meticulous student who attended every lecture and took perfect notes. Marcel generously shared his notes with Albert, helping him pass exams despite his spotty attendance. Albert also fell in love again, this time with Mileva Maric, the only woman in their physics program. Mileva was from Serbia, serious and intelligent, with a limp from childhood illness and a passion for physics that matched Albert's own. They studied together in the library, sunlight streaming through tall windows, dust motes floating in the air. They walked beside Lake Zurich, watching boats with white sails glide across blue water, discussing electromagnetic waves and atomic theory. They dreamed of becoming physicists together, partners in science and life. But their relationship faced obstacles. Albert's mother Pauline despised Mileva, thinking her too old, too serious, too foreign for her son. "She's a book like you," Pauline wrote disapprovingly. "You ought to have a wife." Albert ignored his mother's objections, as he ignored most things that didn't interest him. The lost years, patent office clerk. Albert graduated in 1900, expecting to become a university assistant, the traditional first step toward an academic career. But no position came. Professor Weber, still irritated by Albert's independent streak, didn't recommend him. Other professors barely knew him since he'd skipped so many classes. For 2 years, Albert struggled. He took temporary teaching positions at boarding schools, jobs that paid poorly and left him feeling empty. He sent applications to universities across Europe. All were rejected. He grew increasingly desperate and depressed. Meanwhile, Mileva became pregnant. They married quietly in 1903, a simple ceremony with no family present. Their daughter Liesel was born before the wedding, a scandal in that era. The baby's fate remains mysterious. She either died young or was given up for adoption. Albert never saw her and rarely mentioned her, a source of pain he kept private. Finally, in 1902, Marcel Grossman's father helped Albert get a job at the Swiss Patent Office in Bern. The position was humble, technical expert. Third class. Albert sat at a desk in a large room with other clerks, reviewing patent applications for new inventions. Many people would see this as failure, a physics graduate working as a patent clerk, evaluating other people's inventions instead of making his own discoveries. But for Albert, the job was perfect. The work was easy. He could finish his daily assignments in a few hours, leaving time to think about physics. The patent office was quiet, with high ceilings and large windows letting in Swiss sunlight. His desk faced a clock tower, its hands slowly marking time while Albert's mind raced through space. Evaluating patents taught Albert to strip ideas to their essence, to see what was truly novel versus what was merely complicated. This skill would prove invaluable. And Bern itself was beautiful, a medieval city with arcaded streets, the river Aura flowing through it, the Alps visible in the distance. Albert walked to work along cobblestone streets, past shops with colorful awnings, breathing the crisp Swiss air. In the evenings, he and his friends formed the Olympia Academy, a grandiose name for three young men meeting in Albert's small apartment to discuss philosophy, science, and ideas. They smoked pipes, drank wine, ate sausages and cheese, and debated late into the night, candlelight flickering on the walls. These were the lost years by conventional standards. No publications, no academic position, no recognition, just a clerk sitting at a desk, apparently going nowhere. But in Albert's mind, a revolution was brewing. The miracle year, 1905. In 1905, Albert Einstein was 26 years old, working full-time at the patent office, living in a cramped apartment with his wife and infant son Hans Albert. By every external measure, he was nobody special, just another government clerk among thousands. But that year, in a burst of creativity that remains unmatched in science, Albert published 4 papers that revolutionized physics. Scientists call it the Annus Mirabilis, the miracle year. The first paper, published in March, explained the photoelectric effect, how light hitting metal creates electricity. Albert proposed something radical: light, which everyone thought was a wave, also behaves like particles. These light quanta, later called photons, carried specific amounts of energy. The idea was revolutionary. It suggested that light was both a wave and a particle, depending on how you looked at it. This work would eventually win Albert the Nobel Prize and help found quantum mechanics. The second paper, published in May, proved that atoms, which many scientists still doubted existed, were real. Albert analyzed pollen grains dancing randomly in water, Brownian motion, and showed mathematically that this dance was caused by invisible atoms bumping the pollen. The third paper, published in June, introduced special relativity. Albert started with a simple question: what would happen if you traveled at the speed of light? He realized that space and time aren't absolute. They're relative to the observer's motion. If you traveled close to light speed, time would slow down for you. Space would contract. What seemed simultaneous to you wouldn't be simultaneous to someone standing still. The universe was stranger and more wonderful than anyone had imagined. The fourth paper, published in September, contained the most famous equation in science: E equals mc squared. Energy equals mass times the speed of light squared. This simple equation revealed that mass and energy are interchangeable. Matter is frozen energy, and energy can become matter. This insight would eventually explain how the sun shines and make atomic energy possible. Albert wrote these world-changing papers at night and on weekends, sitting at his kitchen table in his small apartment. The room was humble, simple furniture, a lamp casting warm light on his papers. the sounds of burned streets drifting through the window. His infant son slept in the next room. Maliva worked on calculations, helping with some of the mathematics. When the papers were published in the prestigious journal Annalen Physik, they created barely a ripple. Most physicists didn't understand them. Some dismissed them as wrong. A few brilliant minds, including Max Planck, the founder of quantum theory, recognized their importance. But the wider world remained ignorant. Albert went back to his desk at the patent office, back to reviewing inventions, as if nothing had happened. But he had just rewritten the rules of the universe. Climbing recognition. Slowly, like sunrise illuminating a mountain peak, recognition came. Max Planck, one of the most respected physicists in Europe, understood Albert's relativity theory and began discussing it in lectures. Other scientists started paying attention to this patent clerk from Bern. In 1908, Albert received his first academic position, a low-level teaching job at the University of Bern. He taught early morning classes to a handful of students, barely making more money than at the patent office. But it was a start. The lecture hall was cold in the Swiss winter, his breath visible in the unheated room. His few students sat bundled in coats, taking notes as Albert explained the mysteries of thermodynamics and radiation. He wasn't a natural lecturer. He was too absorbed in the ideas to care much about presentation. But his passion for physics was contagious. In 1909, the University of Zurich offered Albert a proper professorship. At 30, he could finally quit the patent office and become a full-time academic. He was thrilled but also nostalgic for his quiet desk by the clock tower, where he'd done his greatest work without the pressures of academic life. Academic life brought new pressures. Albert had to teach classes, attend faculty meetings, publish papers, and deal with university politics, all things he found tedious. He preferred thinking about physics to talking about it, preferred solving problems to attending committee meetings. His marriage to Maliva was deteriorating. The joy they'd shared as students had faded under the stress of poverty, child-rearing, and Albert's growing fame. Maliva had given up her own physics dreams to support Albert's career, and resentment grew. Their apartment, which should have been filled with joy over Albert's success, instead echoed with tense silences and suppressed arguments. But Albert's star kept rising. In 1911, he was invited to the prestigious First Solvay Conference in Brussels, where the world's greatest physicists gathered to discuss quantum theory. The conference took place in a grand hotel, with crystal chandeliers casting light on Europe's intellectual elite. Albert, still young and relatively unknown, found himself among legends: Marie Curie, Henri Poincaré, Max Planck, Ernest Rutherford. They debated the strange new quantum world where particles could be in two places at once, where observation affected reality, where certainty gave way to probability. A famous photograph from that conference shows Albert sitting among these giants, looking slightly uncomfortable in his formal clothes, his wild hair barely tamed, but his eyes bright with intensity. He was no longer just a patent clerk. He was becoming one of them. The quest for general relativity. But Albert wasn't satisfied. Special relativity, published in 1905, only worked for objects moving at constant speeds. What about accelerating objects? What about gravity? For the next 8 years, Albert wrestled with gravity, the force that keeps our feet on the ground, that makes apples fall, that holds planets in orbit around the sun. Newton had described gravity's effects beautifully, but not what gravity actually was. Albert had an insight while sitting at his desk in the patent office back in 1907. If you were falling freely, you wouldn't feel gravity. A person in a falling elevator wouldn't feel their weight. They'd float as if in space. He called this the happiest thought of my life. This thought led to a radical idea. Gravity wasn't a force pulling on objects. It was the curvature of space-time itself. Massive objects like the sun bent space-time around them, and other objects followed those curves, like marbles rolling around a bowl. But translating this idea into mathematics was brutally difficult. Albert needed mathematical tools he didn't have. Fortunately, his old friend Marcel Grossman, now a mathematics professor, taught him tensor calculus, complex mathematics dealing with curved spaces. For years, Albert filled notebooks with equations, trying different approaches, hitting dead ends, starting over. He worked at the University of Prague, then back in Zurich, then in Berlin, where he moved in 1914 to take a prestigious position at the Prussian Academy of Sciences. Berlin was an intellectual capital, with wide boulevards lined with linden trees, grand buildings housing museums and universities, cafes filled with artists and thinkers. But it was also increasingly militaristic, preparing for the war that would soon engulf Europe. Albert's personal life collapsed. Maliva refused to move to Berlin with him. Their marriage was over. She returned to Zurich with their 2 sons. Albert was alone in Berlin, his genius recognized, but his heart heavy. World War I began in August 1914. Europe descended into brutal warfare. Millions died in trenches filled with mud and blood. Poison gas drifted across battlefields. Cities were bombed. But Albert, a Swiss citizen living in Germany, remained neutral and pacifist. While other scientists supported their nation's war efforts, Albert spoke against nationalism and war. He signed manifestos calling for peace, even as bombs fell on European cities. This made him unpopular with German nationalists. But Albert never cared much about popularity. Through the war years, even as the world burned, Albert continued working on general relativity. In his Berlin apartment, working by lamplight while war raged across Europe, he finally completed his theory. In November 1915, Albert presented his general theory of relativity to the Prussian Academy. The equations were beautiful and complex, describing how mass and energy curve spacetime, how gravity emerges from geometry, how the universe itself is dynamic, expanding or contracting, not static. The theory made specific predictions. Gravity should bend light. Clocks should run slower near massive objects. The orbit of Mercury should precess in a specific way that Newton's theory couldn't explain. When Albert calculated Mercury's orbit using his new equations and got the exact right answer, he was so excited he felt heart palpitations. For a few days, I was beside myself with joyous excitement. He later wrote. But Europe was at war. Few people paid attention to abstract theories about curved space-time when young men were dying in trenches. Albert's greatest achievement seemed destined for obscurity. The eclipse, fame arrives. The war finally ended in November 1918. Europe was devastated, millions dead, economies shattered, empires collapsed, but science began to recover. Sir Arthur Eddington, a British astronomer and pacifist, was one of the few who understood Einstein's relativity theory. General relativity predicted that gravity would bend light, that stars near the sun would appear shifted from their true positions. But you could only test this during a solar eclipse, when stars became visible near the sun's edge. In 1919, Eddington led expeditions to observe a total solar eclipse. One team went to the island of Principe off Africa's west coast, another to Sobral in Brazil. The eclipse was scheduled for May 29th. The day arrived with cloudy skies in Principe, threatening to ruin everything. But as totality approached, the clouds parted just enough. The sun's corona blazed around the moon's black disk. Stars appeared near the darkened sun. Eddington's team photographed them quickly, their hearts racing, knowing they might be capturing evidence that would change physics forever. Months passed while they developed and analyzed the photographic plates, measuring star positions with painful precision. The measurements were close to Einstein's predictions, though not perfect. On November 6, 1919, a joint meeting of the Royal Society and the Royal Astronomical Society was held in London. The room was somber and magnificent, dark wood paneling, portraits of famous scientists watching from the walls. Britain's finest minds gathered in rows of seats. The Society's president announced the results. Einstein's theory is correct. Light is bent by gravity as Einstein predicted. Newton's theory, which has stood for over 200 years, needs to be revised. The room erupted in amazed discussion. After the meeting, the news spread like wildfire. The next day, the London Times ran the headline, "Revolution in Science. New Theory of the Universe. Newtonian Ideas Overthrown." Overnight, Albert Einstein became the world's most famous scientist. Celebrity and burden. Fame transformed Albert's life. Journalists besieged him, wanting interviews. Photographers followed him through Berlin's streets, cameras clicking as he walked. Crowds gathered when he gave lectures. He received thousands of letters from strangers, some asking scientific questions, others proposing marriage or requesting money, still others sharing crackpot theories. Albert found fame bewildering and often annoying. He had always been a private person who cared about ideas, not attention. Now he was a celebrity, expected to have opinions on everything from politics to fashion. He handled it with humor and grace. When asked to explain relativity simply, he said, "Put your hand on a hot stove for a minute, and it seems like an hour. Sit with a pretty girl for an hour, and it seems like a minute. That's relativity." He became an icon. His wild, unkempt hair, his rumpled clothes, his mismatched socks. He refused to wear socks under his shoes, finding them unnecessary. His absent-minded professor persona. Cartoonists loved him. He appeared in newspapers worldwide, usually drawn with crazy hair and surrounded by incomprehensible equations. But fame had dark sides. As a Jewish scientist in Germany, Albert became a target for rising anti-Semitism. The Nazi movement was growing, and they hated everything Albert represented. He was Jewish, intellectual, pacifist, and internationalist. Far-right groups attacked Jewish physics as corrupting German science. They held rallies denouncing relativity as Jewish mysticism. Some even threatened Albert's life. He needed police protection at times. Albert responded by embracing his Jewish identity more strongly, supporting Zionism and fundraising for Hebrew University in Jerusalem. He traveled extensively to America, Britain, Palestine, Japan, spreading his message of science, peace, and international cooperation. Everywhere he went, crowds gathered. In New York, ticker tape parades welcomed him. In Japan, thousands lined streets to catch a glimpse. He met presidents, prime ministers, artists, and intellectuals. Charlie Chaplin became a friend, and when they attended a movie premiere together in Los Angeles, crowds mobbed them both. "They cheer me because everyone understands me," Chaplin said, "and they cheer you because no one understands you." Albert laughed at the truth in that joke. Personal struggles and second marriage. Despite outward success, Albert's personal life remained complicated. His divorce from Maliva was bitter. They fought over money and custody of their sons. Albert felt guilty for the separation, but also relieved to be free from a marriage that had become painful. In 1919, Albert married his cousin Elsa Einstein, a warm, practical woman who didn't care much about physics but cared deeply about Albert. She managed his correspondence, organized his schedule, and protected him from the constant demands of fame. Their apartment in Berlin was comfortable, filled with books, his violin resting in the corner, large windows overlooking the city. Elsa made sure Albert ate, dressed properly, and didn't get too lost in his thoughts. She was more caretaker than intellectual partner, but Albert appreciated her devotion. His relationship with his sons was strained. Hans Albert, the elder, eventually became an engineer, defying his father's hope that he'd become a scientist. Edward, the younger son, was brilliant and sensitive but developed schizophrenia in his 20s, a tragedy that broke Albert's heart. Edward spent much of his life in psychiatric institutions, and Albert's guilt over the divorce and his frequent absences haunted him. Albert threw himself into physics, working on what would consume the rest of his life, a unified field theory. He wanted to unite gravity and electromagnetism into one beautiful theory, to find the deepest laws of nature. But this quest would prove elusive. While younger physicists embraced quantum mechanics, the strange theory of the atomic world, Albert grew increasingly skeptical of its probabilistic nature. God does not play dice with the universe, he famously declared, rejecting the idea that chance and probability were fundamental to reality. This put Albert at odds with many colleagues, including Niels Bohr, who defended quantum mechanics. The Einstein-Bohr debates became legendary, two giants of physics disagreeing profoundly about the nature of reality. Escape from Hitler. In 1933, everything changed. Adolf Hitler and the Nazi Party took power in Germany. The Nazis immediately began persecuting Jews, removing them from universities, burning books, spreading hatred. Albert was traveling abroad when Hitler became chancellor. Friends urged him not to return to Berlin. His life would be in danger. The Nazis had already raided his summer house, frozen his bank accounts, and put a price on his head. Albert never returned to Germany, the country of his birth. His books were burned. His citizenship was revoked. The Nazis confiscated his property. Everything he had built in Berlin was lost. I shall never set foot on German soil again, Albert declared. He resigned from the Prussian Academy and looked for a new home. The Institute for Advanced Study in Princeton, New Jersey, offered him a position. In October 1933, Albert arrived in America, intending to stay temporarily. He would never leave. Princeton was a quiet college town with tree-lined streets, brick buildings covered in ivy, and an atmosphere of scholarly peace, so different from Berlin's turmoil. The Institute gave Albert an office, a blackboard, and freedom to think without teaching obligations. He and Elsa settled into a modest house on Mercer Street, a two-story wooden structure painted white, with a small garden where Albert could sit and think. The house was simple but comfortable, filled with books and papers, with Albert's violin nearby for when he needed to think through a problem musically. America fascinated and sometimes puzzled Albert. It was more informal than Europe. People called him Albert instead of her professor, Dr. Einstein. It was louder, brasher, more commercial, but it was also free, democratic, and welcoming to refugees like himself. War and the bomb. Albert had left violence behind in Europe, but violence followed him. World War II began in 1939 when Nazi Germany invaded Poland. Europe plunged into darkness again, bombs, death camps, genocide. In August 1939, several physicists visited Albert at his summer cottage on Long Island. They brought disturbing news. German scientists were researching nuclear fission. Hitler might be building an atomic bomb. Albert understood immediately what this meant. His equation E equals mc squared had shown that tiny amounts of matter could release enormous energy. A bomb based on nuclear fission could destroy an entire city. In Hitler's hands, such a weapon would be catastrophic. After much thought, Albert signed a letter to President Franklin Roosevelt, warning about the danger and urging America to develop atomic weapons before Germany did. The letter helped launch the Manhattan Project, the secret program that would eventually build the atomic bomb. But Albert himself didn't participate in the Manhattan Project. His pacifist views and foreign birth made him a security risk in the eyes of U.S. military officials. He spent the war years at Princeton, continuing his work on unified field theory, largely unaware of the massive bomb-building effort his letter had helped initiate. On August 6, 1945, the United States dropped an atomic bomb on Hiroshima, Japan. 3 days later, another bomb fell on Nagasaki. The two bombs killed over 200,000 people instantly, with many more dying from radiation later. The war ended, but the nuclear age had begun. When Albert learned about Hiroshima, he was devastated. "Oh, woe is me," he said simply. His equation, his theories about mass and energy, had helped make possible the most destructive weapons ever created. For the rest of his life, Albert campaigned for nuclear disarmament and world government. He believed nations needed to give up some sovereignty to prevent nuclear war. He spoke out against the arms race, the Cold War, the nuclear proliferation that made the world increasingly dangerous. "The unleashed power of the atom has changed everything save our modes of thinking," Albert wrote, "and thus we drift toward unparalleled catastrophe." Final years, the lone genius. In his later years, Albert became increasingly isolated from mainstream physics. While the younger generation embraced quantum mechanics and nuclear physics, Albert continued his lonely quest for a unified field theory, a single, elegant theory that would explain all of nature's forces. He worked every day in his office at the Institute for Advanced Study, a modest room with a desk, a blackboard covered in equations, and windows overlooking Princeton's trees. His hair had turned completely white and grew wilder with age. He wore simple clothes, baggy sweaters, no socks, comfortable shoes. He looked like everyone's image of a mad scientist, except his eyes remained sharp, curious, penetrating. Princeton suited him. He walked to his office every morning, his worn leather briefcase under his arm, greeting neighbors along the tree-lined streets. In autumn, leaves crunched under his feet. In winter, snow covered the sidewalks and turned the campus into a peaceful white wonderland. In spring, cherry blossoms bloomed pink and fragrant. Children in the neighborhood loved Professor Einstein. He would stop to help them with homework, patiently explaining mathematics on their kitchen tables. He bought ice cream for kids on hot summer days. He sailed a small boat on Lake Carnegie, though he never learned to swim, content to drift and think while water lapped against the hull. Elsa had died in 1936, leaving Albert alone in the Mercer Street house. His sister Maya moved in to keep him company, but she suffered a stroke and spent her final years bedridden. Albert read to her every evening, Greek classics, philosophy, novels, his voice gentle in the quiet house. Albert received constant visitors, scientists wanting to discuss theories, politicians seeking his support for causes, journalists requesting interviews, strangers hoping to meet the famous genius. He was gracious to most, though increasingly weary of fame's demands. His secretary, Helen Dukas, protected him fiercely, screening visitors and correspondence. She managed his household, organized his papers, and became part of his family. Without her dedication, Albert would have drowned in the ocean of demands on his time. The search for unity. Despite mainstream physics moving away from his quest, Albert never stopped searching for his unified theory. Every day, He covered blackboards with equations, trying different mathematical approaches to unite gravity and electromagnetism. His office blackboard was a window into his mind. Equations sprawled across it in his handwriting. Some crossed out, others circled, arrows connecting different ideas. He would stand before it for hours, chalk in hand, lost in thought, occasionally writing a new line, sometimes erasing everything and starting fresh. Younger physicists thought Albert was wasting his time. Quantum mechanics was revolutionizing physics, discovering new particles, explaining atomic structure, making predictions that experiments confirmed. They urged Albert to accept quantum theory and move forward. But Albert couldn't accept a universe built on probability and chance. He believed in determinism, that everything has a cause, that God doesn't play dice, that beneath quantum mechanics' apparent randomness lay deeper laws waiting to be discovered. "I believe in Spinoza's God," Albert said, "who reveals himself in the orderly harmony of what exists, not in a God who concerns himself with the fates and actions of human beings." For Albert, physics was a spiritual quest to understand the mind of God, not a personal deity, but the rational order underlying reality. The universe was a symphony, and he wanted to read the composer's score. He never found his unified theory. The mathematics proved too difficult, or perhaps the theory he sought doesn't exist in the form he imagined. But his search wasn't futile. It inspired future generations of physicists who still seek a theory of everything that unites all forces of nature. Civil rights and social justice. Fame gave Albert a platform, and he used it to speak out on social issues, particularly civil rights. America in the 1940s and 50s was deeply segregated, with Black Americans facing systematic discrimination, violence, and oppression. Albert was horrified by American racism. Having fled Nazi Germany's persecution of Jews, he was sensitive to all forms of prejudice. He called racism America's worst disease and used his voice to fight it. He joined the NAACP and financially supported civil rights organizations. When the famous Black singer Marian Anderson was denied a hotel room in Princeton due to her race, Albert invited her to stay at his house. She did, and they became friends. Anderson later said Albert was one of the kindest people she'd ever met. When a Black student at Princeton wrote to Albert saying he felt isolated and unwelcome, Albert invited him to his home regularly for conversations and support. Albert understood loneliness and being different. The FBI monitored Albert for his political activities, building a file over 400 pages long. J. Edgar Hoover, the FBI director, suspected Albert of communist sympathies. The truth was simpler. Albert believed in justice, peace, and human dignity. He spoke against racism, militarism, and nationalism because these things violated his deep humanistic values. "I speak to everyone in the same way," Albert said, "whether he is the garbage man or the president of the university." This wasn't just words. Visitors to his Princeton home might find him chatting with the mailman about philosophy, or discussing politics with a plumber fixing his sink. Albert treated everyone with the same respect, curious about their lives and ideas. The letter that never arrived. In the spring of 1955, Albert's health was failing. He suffered from heart problems and an abdominal aortic aneurysm, a dangerous bulge in a major blood vessel. Doctors warned him it could rupture at any time. Albert refused surgery. "I want to go when I want," he said. "It is tasteless to prolong life artificially. I have done my share. It is time to go. I will do it elegantly." On April 13th, 1955, the aneurysm ruptured. Albert collapsed in his Princeton home, clutching his stomach in pain. He was taken to Princeton Hospital, A modest brick building where spring sunshine streamed through the windows onto white walls and polished floors. Doctors urged surgery. Albert refused. He had lived 76 years, achieved more than most people dream of, and felt ready for the end. He asked for his latest equations, sheets of paper covered with his handwriting, his final attempts at unifying the laws of nature. They brought the papers to his hospital room, and Albert studied them, making corrections, still searching for answers even as his body failed. The room was quiet except for the tick of the wall clock and the distant sounds of the hospital, nurses' footsteps in the hallway, soft voices, the ordinary sounds of life continuing. On his bedside table sat an unfinished draft of a speech he'd been preparing for Israeli Independence Day. It called for peace and understanding between nations, for cooperation instead of conflict, for reason over emotion. Albert's secretary Helen Dukas visited, as did his son Hans Albert, who had traveled from California. They sat with him in that hospital room, spring sunshine warming the space, saying goodbye without saying the word. In the early morning hours of April 18th, 1955, a nurse checked on Albert. He muttered something in German, his native language, the language of his childhood in Ulm. The nurse didn't understand German. She would never know what his final words were. At 1:15 a.m., Albert Einstein died quietly. The greatest scientific mind of the 20th century simply stopped breathing, as peacefully as falling asleep. The legacy that changed the world. Albert's body was cremated, his ashes scattered in an undisclosed location. He wanted no grave that could become a shrine, no monument to his ego. The ideas mattered, not the man. But the world mourned. Newspapers worldwide ran obituaries celebrating his life. Flags flew at half-staff. Strangers wept for a genius they'd never met, but whose work had touched their understanding of reality. The Institute for Advanced Study lowered its flag. The blackboard in Albert's office, still covered with his final equations, was left untouched for years, a sacred relic of genius at work. What Albert left behind was more than theories and equations. He fundamentally changed how we understand the universe. Relativity revealed that space and time are not absolute, but flexible, warped by mass and energy. Time flows differently depending on your speed and proximity to gravity. The universe is not a static stage, but a dynamic, curved space-time fabric. E equals mc squared showed that matter and energy are interchangeable, explaining how stars shine, how the sun produces light and heat, how atomic energy works. This tiny equation unlocked the power in atoms and revealed the universe's deepest secret. Everything is made of frozen energy. His work helped establish quantum mechanics, even though he spent years arguing against its probabilistic interpretation. His paper on the photoelectric effect was foundational to quantum theory, earning him the Nobel Prize. His theories enabled GPS technology, which depends on relativistic corrections to satellite clocks, modern electronics, nuclear power, particle accelerators, our understanding of black holes and the Big Bang, all rest on foundations Albert laid. But beyond specific discoveries, Albert changed how we think about science. He showed that imagination and thought experiments matter as much as laboratory work, that beauty and simplicity are guides to truth, that the universe operates on principles we can understand through pure reasoning combined with observation. Lessons from a genius. What can we learn from Albert Einstein's extraordinary life? First, curiosity is more important than intelligence. Albert wasn't the smartest student in his classes. He was the most curious. His constant question, why, drove everything he did. I have no special talent, he said. I am only passionately curious. Second, Failure and rejection don't define you. Albert failed his university entrance exam. He couldn't find an academic job after graduation. He was rejected repeatedly. But these setbacks didn't stop him. They redirected him to a patent office where he had time to think deeply. Third, think differently. Albert's greatest discoveries came from questioning assumptions everyone else accepted. He asked, what if you could ride a beam of light? What if time isn't absolute? What if gravity isn't a force but curved space? Obvious questions nobody else asked led to revolutionary answers. Fourth, persist in the face of doubt. For years, most scientists ignored or rejected relativity. Albert's unified field theory quest was mocked, but he trusted his intuition and kept working. Sometimes being wrong, according to others, means being ahead of your time. Fifth, balance matters. Albert wasn't just a scientist locked in a laboratory. He played violin, sailed boats, enjoyed nature, read philosophy and literature. He believed science without humanity was empty. The most beautiful thing we can experience is the mysterious. He wrote, it is the source of all true art and science. Sixth, stand for justice. Despite fame and pressure to stay silent, Albert spoke against war, racism, and oppression. He risked his reputation for what he believed was right. Genius without conscience is dangerous. Albert showed that brilliant minds should serve humanity. Seventh, stay humble. Despite being the world's most famous scientist, Albert remained simple and unpretentious. He wore the same old sweater, walked to work, helped neighborhood children with homework. Everyone is a genius, he said, but if you judge a fish by its ability to climb a tree, it will live its whole life believing it is stupid. The continuing revolution. Today, more than 70 years after Albert's death, his influence remains everywhere. His face, wild hair, thoughtful eyes, gentle smile, is one of the most recognizable in the world. His image represents genius itself in popular culture. Scientists continue building on his foundations. The Laser Interferometer Gravitational Wave Observatory, LIGO, detected gravitational waves in 2015, ripples in space-time caused by colliding black holes. Exactly as Albert predicted a century earlier, each detection proves again that he was right about the nature of space-time. The Hubble Space Telescope and its successor, the James Webb Space Telescope, observe the universe using principles Albert established. They see galaxies bent around massive objects, gravitational lensing, another prediction of general relativity. They study the Big Bang's aftermath, the expansion of space, phenomena Albert's theories explained. Particle accelerators smash atoms at nearly light speed, confirming every day that E equals mc squared is true. Nuclear power plants convert matter to energy exactly as Albert's equation predicted. Medical imaging technologies like PET scans depend on the matter-energy equivalence Albert discovered. Even technologies Albert never imagined rest on his insights. GPS satellites need relativistic corrections, without accounting for time dilation from their speed and altitude. GPS would fail within minutes. Your smartphone literally couldn't tell you where you are without Albert's theories. The human side of genius. But perhaps Albert's greatest gift was showing that genius doesn't require perfection. He made mistakes in physics and in life. He was wrong about quantum mechanics, or at least, the scientific consensus says so. His marriages struggled. His relationships with his children were complicated. He could be stubborn, difficult, absent-minded, and occasionally thoughtless. He wasn't a plaster saint or a superhuman intellect beyond understanding. He was a human being who loved music, enjoyed sailing, made jokes, felt loneliness, struggled with personal relationships, and doubted himself at times. This makes his achievements more inspiring, not less. Albert didn't succeed despite being human. He succeeded because he was human, with human curiosity, imagination, and determination. His life says to each of us, you don't need to be perfect to make a difference. Your unique perspective matters. Your questions are valid. Your curiosity is valuable. Don't let anyone tell you that you'll never amount to anything. The teachers who said that to Albert were spectacularly wrong. Conclusion: the universe according to Einstein. On a clear night, look up at the stars. They seem fixed and eternal, distant points of light in an unchanging sky. But Albert Einstein taught us differently. That starlight has traveled through curved space-time, bent by gravity, taking routes determined by the mass-energy distribution of the universe. Time itself flows differently on those distant stars than it does for you standing on Earth. The atoms in your body contain frozen energy equal to several nuclear bombs. Space and time are not separate but woven together into a four-dimensional fabric. The universe, according to Albert Einstein, is far stranger and more wonderful than common sense suggests. It's a place where time is relative, where space curves, where matter and energy dance in eternal transformation, where gravity is geometry itself. This understanding, this new vision of reality, came from a patent clerk sitting at a kitchen table, a professor standing before a blackboard, a gentle man walking Princeton streets with wild hair and no socks. Albert Einstein was born in Ulm, Germany, in 1879, a baby with an oddly shaped head who didn't speak until he was 4. He was told he would never amount to anything. He failed entrance exams. He couldn't find a job. He spent years in obscurity. But he never stopped asking questions, never stopped wondering, never stopped searching for the hidden harmonies that govern reality. And in the end, he gave humanity a new universe, one more beautiful, more mysterious, more awe-inspiring than we had imagined. His equations are carved in stone, his theories tested by countless experiments, his insights woven into the fabric of modern technology and thought. But more than that, Albert Einstein left us a gift more precious than any equation: the permission to wonder, the courage to question, the conviction that curiosity and imagination can unlock the deepest secrets of existence. Look up at the stars tonight and remember, a curious child with a compass, a rebellious student who asked why, a humble patent clerk with big dreams. He changed how we see everything. What will your curiosity reveal? The end. The important thing is not to stop questioning. Curiosity has its own reason for existing. Imagination is more important than knowledge, for knowledge is limited, whereas imagination embraces the entire world. Look deep into nature, and then you will understand everything better. Learn from yesterday, live for today, hope for tomorrow. The important thing is not to stop questioning. Albert Einstein,